We'll be looking at evaluating our limits numerically using a table of values to find the limit. Our first example, we'll look at the limit as x approaches 2, and our function will be x minus 2 over x squared minus 4. Setting up our table of values using x and f of x, or x and our y values. We'll set up our table since we're looking at the limit as x approaches 2. 2 will go in the middle of our table. We want to think of numbers that come from the left side of 2 and from the right side of 2. So from the left side of 2, a number close to it would be 1.999. Another number that's quite close but not as close would be 1.99. And then the other number would be 1.9. So these three values represent coming close to 2 from the left side. Now we'll set up our table of values to come close to 2 from the right side, which would be 2.1. Even closer would be 2.01, and 2.001 would be even closer. So these three values represent coming close to 2 from the right side. So as we look at our table of values, you can see we'll be coming from the right side and coming from the left side of 2 to figure out what our limit is going to approach. So these y values should be approaching some limit number. We'll call that limit number L. We use our graphing calculator to approximate. Set up your table for the independent variable to be ask. Then when you look at your table, you can type in your values for x, typing in each of the x values that we have in our table. Recording our y values, 0.256 for 1.9, then 0.251 for 1.99, 0.250 for 1.999. For 2.1, we have 0.244. 2.01 is 0.249, and 2.001 is 0.250. Looking from the left and from the right, we can see that our limit approaches x approaches 2 of f of x is equal to 0.250. Using the TI Inspire, we can set up a table by using Control T, then using Control and the up arrow, then menu, you can ungroup the table. Going into the table, then under your menu, you can edit the table settings, and then set up your independent variable to ask, and then you can type in the values for x, starting with the 1.9, and recording those values in the table on your paper. For our next example, we're going to look at the limit as x approaches negative 3 of our function y squared plus 4y plus 3 over the quantity y plus 3. Setting up our table of values, again with x and f of x, put the value of negative 3 into the middle of the table. I'm going to think of some numbers from the left and the right of negative 3. It may be difficult to think about the numbers for negatives, so if it helps you to set up a number line, make a little number line on the side, think of what values are from the left and from the right of negative 3 to keep that in mind. So from the right of 3, we'll be using the number negative 2.9. A little bit closer will be negative 2.99, and even closer will be negative 2.999. Those will be the values approaching from the right of negative 3. Then from the left of negative 3, using the value negative 3.1, even closer would be negative 3.01, and even closer would be negative 3.001. And those would represent the values from the left. In our calculator, we already had the table set up to ask. We're going to delete those old values by just typing over them using those new x values. Notice all the y values change. So when we set up our values into the table, we'll see as we approach from the left and the right what our values will be. So we record our numbers into our table. And we can see from the left and from the right what are the y values approaching. So our limit as x approaches negative 3 of our function y squared plus 4y plus 3 divided by the quantity y plus 3 is equal to negative 2.